So in this video, what I'm going to be talking about is the periodic table. And just as a quick introduction, if you see for each box that each element exists in, there are three different important pieces of information that you will find. You will find the atomic number, you'll find the atomic symbol, and you'll find the atomic weight. Remember, the atomic number is the number of protons, the symbol is simply the symbol, and then the atomic weight is the weighted average of the atomic masses. So here's your periodic table right here, and just as a quick review, remember that the periods represent the horizontal rows, while the groups represent the vertical columns. The next piece of information that you need to know is that there are three different types of atoms that you can have. The first are metals, and so if you look, all of the elements that are in brown, those are your metals. Now, there are a couple of important pieces of information about metals that you need to know. Metallic elements, they are lustrous. They have luster, meaning they're shiny. They're good conductors of electricity and heat, and they're also solids at room temperature. So notice most elements on the periodic table are actually metals. So what I would do if I were you, the periodic table that I gave you is actually the periodic table you'll have on the AP. So I would color in the metals, then the metalloids, those 6 elements, those share both metallic and also non-metallic characteristics, so that's why they're in between the metals and the non-metals. Now, the green elements, those are your non-metals. Notice all of them except for hydrogen are to the right of that ladder, to the right of the metalloids, and they are either gases, solids, or liquids at room temperature, and all of their other characteristics are opposite of that of metals. So for example, they are not lustrous, they are not good conductors of electricity. And then you have your metalloids. The next thing that we're going to be talking about is molecular compounds. Now, molecular compounds are created by having 2 nonmetals bind together. Now, the way that they're bound together is through a covalent bond, and a covalent bond results from the sharing of electrons, which we'll look at a little bit later on. Now, there are 2 different types of formulas that you can have for molecular compounds. You can have a molecular formula, which represents the actual numbers of atoms in a molecule, versus the empirical formula, which indicates only the relative number of atoms. So it's the smallest possible whole number ratio. Well, the question is, well, why would you have an empirical formula? Why not just the molecular formula? Well, if you have something like C2H4, that is the molecular formula. Now, if I wanted to know, for example, for every 1 carbon, how many hydrogens do I have, that would be your empirical formula. So your empirical formula is the formula that has been reduced to have the smallest possible whole number ratio. And we're going to be looking at how to calculate your empirical and molecular formulas later on. So let's talk really quickly about naming molecular compounds and actually writing out their formulas. So when we're naming molecular compounds, what we're doing is we're actually going to be using prefixes in order to note the number of each atom. And so here are your prefixes that you need to memorize. You've got mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. And so what you would do is you put the prefix in front of the atom's name. The only 2 quick rules, the first one is that you don't actually start with mono. So the very first atom, if you only have one of them, you won't use the prefix mono. Now, if your second atom, there's only one of them, then you can use the prefix mono, but you just don't start. So for example here, BF3, it wouldn't start with monoboron, for example. And then the second thing is that the second atom is going to have an IDE ending at the end of it. So let's look at this first example. I've got P3F4. So this would be triphosphorus because I've got 3 phosphoruses. And then I've got 4 fluorine, so it would be tetra. And instead of fluorine, I'm going to add an IDE ending, so it would be tetrafluoride. And that's it. Okay. Now, the reverse, if I have the name and I'm needing to write out the formula, for nitrogen, I know I only have one of them because there's no prefix here, so it's just going to be N. And then I've got trichloride, so I know that's Cl. And there are 3 chlorines, so the formula would be NCl3. Now, the other thing that we need to talk about, now that we've talked about molecular compounds, is we need to talk about ionic compounds. But in order to talk about ionic compounds, we need to talk about what happens when atoms, instead of sharing electrons, when they actually lose or gain electrons. And what forms when atoms lose or gain electrons is ions. Now, if you have a positively charged ion, that is a cation, while a negatively charged ion is an anion. And so what happens, for example, if sodium were to lose one electron, it would have a charge of +1. Now, chlorine, if it gains that one electron, it would have a charge of -1. And so what you need to know is that metals tend to lose electrons and they therefore become cations, while nonmetals gain electrons to become anions. And so that's why if you have an ionic compound, it's between a metal, which lost the electron, and a nonmetal, which gained the electron or electrons. Okay, and the last important thing for you to know is that the chemical properties of ions, so for example, sodium ion is very different from sodium atoms. Sodium ions exist in your body, while sodium atoms, they react extremely exothermically. They actually explode if you put them in water. So those are not in your body. It's the sodium ions that are in your body. And so if you look here, this is an ionic compound, and it results from the transfer of electrons, so you'll have a positive and a negatively charged ion. Now notice that the positively charged sodium ion is going to be surrounded by chloride ions completely. So when we're talking about ionic compounds, you don't actually have just one molecule. Instead, you have billions of sodium ions and chloride ions that surround each other in this very nice structured form that's called a crystal lattice structure. And so that's why salt looks like crystals, because they are crystals. And so we don't use the term molecule if you're counting the number of molecules. You use that term when you're talking about molecular compounds, but for ionic compounds we talk about formula units, simply because you're not going to just have one molecule of NaCl. Instead, you're going to have this huge crystal lattice structure. So one of the beautiful things about the periodic table is it actually allows us to predict the charge that ions will form. And so what I'm going to do, I'll explain later on how to determine the number of valence electrons, but right now I just wanted to remind you that the atoms in group 1, when they form ions, they assume a charge of +1. Okay? Atoms in group 2 assume a charge of +2. In group 3, +3. And then once you get to group 5, it's going to be -3, -2, -1, and 0. Okay, so this is going to come into play when we're talking about ionic compounds just a little bit later. So an important thing for you to know is that when ionic compounds form, their overall charge is going to be neutral, and so that's going to help us when we're writing out the empirical formula. Now note, ionic compounds do not have a molecular formula, because if you have, for example, NaCl, you never write Na3Cl3 if you had 3 of each of them. That you're not going to just have 3. The empirical formula for an ionic compound is the only formula we have, because for every one sodium ion you have one chloride ion. So while you'll have molecular and empirical formulas for molecular compounds, you will not for ionic compounds. And so when we're writing the formula for an ionic compound, you're going to take the two charges and you're going to cross them. So the 2 from magnesium becomes the subscript for nitrogen, and the 3 from the nitride ion becomes the subscript for magnesium. And the reason why you do this, if you look, magnesium has a +2 charge. And so if you have 3 magnesiums, that would be a total charge of +6. Nitrogen has a -3 charge, but since you have 2 of them, that would be a -6 charge, and so their charges actually cancel. So the concept of crossing charges makes this creation of a neutrally charged compound very easy for you. So if you look at this example, you've got sodium sulfide. So sodium has a +1 charge. Sulfur, or sulfide, has a -2 charge. And so when you cross your charges, what you're going to get is Na2S. Now the last thing I'm going to be talking about is actually naming the ionic compound. So now we're not going to write the formula, we're going to name it. And so if you have an ionic compound, you've got 2 situations that you can be in. The first one is if you have a cation from a metal whose charge you know. So for example, any group 1, group 2, or group 3 metal, you know its charge is always +1, +2, or +3. And so I do not need to include the charge of the metal when I'm writing the name. However, if I have a metal whose charge I do not know or can have different charges, specifically your transition metals, then you need to represent the charge as a Roman numeral. So for example, iron, if iron had a 2+ charge, you would represent it with an iron with a Roman numeral 2 behind it in parentheses, and then you would continue on just like before. And then for example, for iron 3, it would be iron with a Roman numeral 3. So that's for the cation. For the anion, what you do is you simply write the name of the monatomic anion, and then you add an IDE ending. So instead of chlorine, it would be chloride. So I'm going to show you these two examples, and when you have an ionic compound, the first thing that you need to do when you're looking at it is you need to ask yourself, do I know the charge of my metal? So I've got manganese right there. Remember, if it's not group 1, group 2, or group 3, I do not know the charge of my metal except for two exceptions that you need to write in right now. The first exception is silver. Silver has a +1 charge, and so that's one you're just going to have to memorize. The other exception is zinc, and zinc has a +2 charge. Otherwise, if you're not silver or zinc, or in group 1, group 2, or group 3, you need to include the charge of the metal as a Roman numeral because we do not know the charge of that metal. So for example, if I just wrote manganese sulfide, my first response would be, well, what's the charge of manganese? Because I don't know this formula. All you're telling me is manganese sulfide. And looking at the periodic table, I can't determine that. And so what I would need to do would be I would need to write manganese. And then the next thing I need to do is I need to determine the charge of manganese. Well, sulfur, if I look at the periodic table, has a -2 charge, which means that manganese, in order to cancel out this -2 charge, must have a +2 charge. And so I'm going to include as my Roman numeral just a 2. So it would be manganese 2 sulfide. Because remember, I had an IDE ending for my anion. And so that's all you need to do. So the only different thing that you need to do for metals of charges that you don't know is you need to include the Roman numeral for the charge. If you do know the charge, so for example, if I were to give you CaF2, I look at my metal, which is calcium, and I know the charge of my metal always. My charge of my metal, calcium, is always +2. And so when I write the name for this ionic compound, it would just be calcium fluoride. And that's all I need to do. So what you've got in front of you are your polyatomic ions. Now these polyatomic ions you need to memorize, and you need to spend this summer, you need to take a week or two, and you need to memorize these 25 polyatomic ions. Now, if you notice, there are a couple of things you need to keep in mind. You need to know the charge of these polyatomic ions because that's going to come into play when we're writing out the formulas. But the interesting thing is actually there are way fewer than 25 of them, and that's because a lot of them have stuff in common. So for example, if you look at NO3 with a -1 charge and NO2, notice NO3 is nitrate while NO2 is nitrite. So the only difference between ate and ite is that the ite has 1 fewer oxygen. So if you look at perchlorate, chlorate, chlorite, hypochlorite, there are 4 right there. If you remember that perchlorate is ClO4 minus, then chlorate, you just remove 1 oxygen, so it would be ClO3 minus, chlorite, another oxygen, and then hypochlorite, another oxygen. So notice that there are a lot of trends here and groupings that can really help you to memorize these. But yes, these do need to be memorized by the first day simply because we don't have time to memorize them during the school year. So get working with those, write out flashcards, write them out, and then go further and start completing the practice with ionic compounds and their polyatomic ions, which can be found on the next page. So in this example, I give you an ionic compound, but it's with a polyatomic ion. So don't let this freak you out. Okay. Sodium is my metal. Now remember, for all ionic compounds, I need to decide in my mind, do I know the charge of my metal? Well, sodium has a +1 charge always because it's an alkali metal. Therefore, I know its charge, so I don't need to include a Roman numeral. So I've got sodium, no Roman numeral needed, and then I just need to write out the name of PO4. Well, PO4 is phosphate, so it's just going to be sodium phosphate. And that's it. Now if you look further down on this page for the table that I provided, I'm going to work through the first example problem with you just to explain what you need to do. So it gives you the name of your compound, which is ammonium phosphate, and what you need to decide is it ionic or molecular, and then you need to write out the formula. Well, a really easy way of determining, other than saying, okay, an ionic compound is a metal and a nonmetal, and a molecular compound is two nonmetals. Other than that, a really easy way of doing this is simply by saying, are there prefixes? If there are not prefixes, your compound is ionic. If there are prefixes, then it's going to be molecular. So those are two different ways of determining what type of compound you have. Well, ammonium phosphate doesn't have any prefixes, so I know that this is going to be an ionic compound. And so what I need to do is, in order to write the formula for an ionic compound, I need to cross my charges. Remember, for a molecular compound, you do not need to do that. But I've got NH4, and NH4 has a +1 charge. That's one of my polyatomic ions. And then I've got phosphate, which has a 3- charge. And so to write out this formula, I need to cross my charges. So the 3 is going to become the subscript for NH4, and the 1 is going to be the subscript for PO4. So when I write out this formula, what I get is NH4, 3, PO4, and remember, I don't need to include the 1. Now here's the issue. Right now, the way I have it written, I'm wanting to say I have 3 NH4s, but instead what I've written is I have NH43. And so what you need to do if you have more than one polyatomic ion is you need to include parentheses around it. So it'd be NH4, 3, PO4. Notice I don't need parentheses around PO4 simply because I only have one PO4.